Chapter 6, Section 4, Data Visualization for Bivariate Analysis. This section focuses on visualization methods for bivariate analysis. That is, I will show you how to visualize the relationship between two variables. As visualization methods, let me show 5 methods here. In many cases, we want to visualize one numerical variables by categories. It is a type of bivariate analysis, also called categorical univariate analysis. There are various types of categorical univariate analysis. If we see a numerical variable's representative values by categories, we can use a bar plot. If we focus on the composition ratio, we can use a 100% stacked bar plot. If we are interested in distribution, we can use box plots. For time series data, we can use a line plot. To visualize the relationship between two numerical variables, we can use a scatter plot. A simple case of bivariate analysis is to show summary data by category. For example, we can compare average level of work motivation between job categories in our company. Suppose we measure work motivation by 7-point Likert scale. This is the aggregated data. The most common way to visualize categorical data is using a bar plot, also called a bar chart. You already saw a count plot, a type of bar plot that visualizes frequencies. Here, a bar plot should visualize the average, not the frequency. But the structure is the same. Each bar represents a specific category, and the length of the bar represents the value of the category. So, we can create a bar plot, plotting the category on the horizontal axis and the average value on the vertical axis. But in this plot, the rank order of the categories is not clear. So, by sorting the bars in order of length, we can see the rank order clearly. Next, let's consider a case comparing age composition between job categories. In this case, we aggregate the proportion of age groups by categories. For simplicity, let's consider only 3 job categories. As a common way, we can create pie charts by categories. They are stylish, but it is hard to see the similarity and the difference in age composition between categories. In cases where there are more categories and each category is divided into more classes, comparing categories by pie charts becomes impossible. A 100% stacked bar plot is a better way to visualize each category's proportion. A 100% stacked bar plot fixes the vertical axis height as 100% to show the percentage. So, it shows the relative difference between each group clearly. We can say that a 100% stacked bar plot is an excellent way to visualize a cross-tabulation table. There are cases where we want to compare the distribution of a continuous variable between categories. For instance, we can compare the distribution of salesperson's individual sales amount between sales divisions. We can create histograms for each category. However, even if you line up multiple histograms horizontally and vertically, it is not easy for us to see the difference between categories. We can stack 2 histograms to see the difference between the two. However, if we stack 3 or more histograms, it is very hard to see the difference between categories. A better way is to create box plots for each category and line them up horizontally or vertically. We can see the difference between categories more clearly. Even if the number of categories increases, the figure will not become so messy as in the case of histograms. So, when we want to see the distribution of a continuous variable by more than two categories, using box plot is a better way than using histograms. As for time series data, we can visualize time series trend by category using a line plot. We can insert multiple lines into a line plot. Each line represents each category. The lines can be distinguished by colors, or they can be distinguished by line types. Next, let's see how to visualize the relationship between two numeric variables. In such cases, we can use scatter plot. Here, numeric variables include both continuous and discrete variables. A scatter plot uses dots to represent the values of two different numeric variables of each data point, and visualizes the relationship between two variables. A scatter plot partitions the data points by their values of the two variables. Each of the two variables is represented as x-coordinate and y-coordinate, respectively. Let's see how to create a scatter plot. Suppose we have a dataset that records each employee's motivation level and performance level. Both motivation and performances are measured by 7-point scales. Let's create a scatter plot where the horizontal x-axis represents the motivation level and the vertical y-axis represents the performance level. Look at the data of employee 001. His motivation level is 6. So the x-coordinate should be 6. His performance level is 5. So the y-coordinate should be 5. So we can position this employee at the coordinate 6, 5. Similarly, we can position employee 002 and 003. Now we get the scatter plot of these three employees. We have three scatter plots here. Each of them contains data of two variables, x and y. In the left scatter plot, the dots form an upward line. We can see a tendency that as x increases, y also increases. In the center plot, the dots form a downward line. We can see a tendency that as x increases, y decreases. In the right plot, the dots are dispersed randomly. We cannot see any pattern in the relationship between x and y. As we have seen, a scatter plot shows us the relationship between two variables. Thank you for watching. Please thumbs up and subscribe to my channel.